Welcome dear students. In this lecture we are going to discuss what is the relationship between the Gibbs free energy and EMF of the cell. Now this one is the Daniell cell in front of you, in which zinc plate is dipped in 1 molar solution of zinc sulfate, copper plate is dipped in 1 molar solution of copper sulfate. Both these electrodes are connected through voltmeter and the electrolytes are connected through the salt bridge. In this electrochemical cell or galvanic cell, a spontaneous redox reaction takes place which produces electrical energy. And this one is the spontaneous redox reaction in which zinc is being oxidized as its oxidation state is increasing, and copper is being reduced because its oxidation state decreases. So zinc will act as anode and this copper will act as cathode, and according to the convention of the IUPAC, we show the anode on the left hand side and cathode on the right hand side. Now my dear students, when this circuit is completed in this cell produces electric current, or you can say the cell does some work. This cell is a system, so this system does some work, and that is basically the electrical work which is equal to charge multiplied by potential, or you can say volts. Now my dear students, when the zinc is oxidized, then 2 electrons they move from zinc compartment to the cathode compartment. So when these 2 electrons move from anode compartment to cathode compartment, we say that some charge flows from the anode to cathode. A charge moves from anode to cathode. Now, the number of moles of electrons that are moving from anode to cathode here, that is 2, means 2 electrons are moving from anode to cathode, but we will show the number of moles of electrons with the symbol N, and you know that charge on 1 mole of electrons is 1 Faraday, which is no doubt equal to the 96500 coulombs. So the number of moles of electron that are moving from anode to cathode, they are shown with the letter N, and here in this particular case the number of moles of electron moving from zinc to copper, they are 2. So in this case the N is basically equal to 2. But generally we will say that N is the number of moles of electrons that move from anode to the cathode, and the charge on 1 mole of electron is F. So what will be the total charge? The total charge moving from anode to cathode should be equal to N multiplied by F. The number of moles of electron and the charge on 1 mole of electron, when they are multiplied, that will be equal to the total charge that moves from anode compartment to the cathode compartment in the electrochemical cell. Now my dear students, it is just like what should be the mass of a wall. The mass of a wall is equal to the mass of the one brick multiplied by total number of bricks. So here these are total number of bricks actually, and this is the mass of one brick. So that will be equal to total mass of the wall. This is just an analogous example to make you clear what is meant by this total charge N into F. So charge is equal to N into F, and when this charge moves from anode to cathode, there is a force that makes this charge move from anode compartment to the cathode compartment. It is the pushing force actually, that is called as the electromotive force or EMF. Now this EMF, that is shown with the letter E. So E is basically the volts that are produced by this electrochemical cell, or E is the electromotive force, which is the pushing force that pushes the electron from anode compartment to the cathode compartment. So the total charge is N into F, and how many volts are produced, they are shown with the symbol E. So the work here, that will be equal to N into F into E. This one is the formula of the work which is done by the electrochemical cell. Now, from thermodynamics, you know that whenever the work is done by the system, that work is shown with the negative sign. So that's why here this work will also be shown with the negative sign, and we will say that work is equal to minus NF into E. This is the maximum work done by the system or by the cell. And my dear students, you know that the maximum work done by the system in the thermodynamics, we show it with the change in the Gibbs free energy. So we will say that delta G is actually equal to W. According to thermodynamics, the maximum work which is done by the cell, that is equal to the change in the Gibbs free energy of that system. So delta G will be equal to, now put the value of or formula of this work here, that will be equal to minus N into F into E. Now this E is the EMF of the cell, and this one is the relation between the Gibbs free energy change and the EMF of the cell. Under standard conditions or at standard room conditions, now at standard room conditions, and you know what are the standard room conditions, they are 25 degrees C, which is equal to 298 Kelvin, and they are equal to pressure should be 1 atm. Under standard room conditions, the Gibbs free energy, that will be delta G naught. This naught shows the standard conditions, that will be equal to minus N into F into E naught. So this naught is just for the standard room conditions. So this one is the relation between the Gibbs free energy change and EMF of the cell under any condition, and this one is the relationship between the standard Gibbs free energy change and the standard EMF or the standard cell potential. Now my dear students, listen very carefully that for any process to be spontaneous, you know in the thermodynamics you have studied that for all spontaneous processes, delta G is always negative. Now listen very carefully. If delta G should be negative, then E should be positive. N and F both are constant for a cell. N is the number of moles of electrons that travel from anode to cathode. F is the charge on 1 mole of the electron. F is the Faraday's constant. So N and F, they are constant quantities. If E or EMF of the cell will be positive, then this positive number will multiply with this negative, and the answer of the delta G will also be negative, and in that case the spontaneous process will be taking place in that electrochemical cell. Now my dear students, in case of this Daniell cell, you know that E or EMF of the cell, that is positive. In this case, for this particular reaction, the standard cell potential or the EMF of the cell, that is positive 1.10. So if E will be positive, or you can say E naught will be positive, then the delta G naught will be negative, because this positive number when will multiply with this negative sign, the overall answer of the delta G naught will be negative, and then the process will be spontaneous in the electrochemical cell. But my dear student, if we reverse this reaction, suppose that like this, if we will reverse this reaction, now in that case the E naught of the cell will be negative, and because E naught will be negative, so that delta G naught will become positive, because when this negative number will multiply with this negative sign, it will become positive, and delta G naught positive means this process is non-spontaneous. So for delta G or delta G naught, for its positive value, it is, sorry, for its negative value, it is must that E and E naught should be positive. And if E and E naught are negative, then delta G or delta G naught will be positive, and that will be showing the non-spontaneous process. So keep in mind that if delta G is negative, it means E is positive. That will be the spontaneous process. And if delta G is positive, it simply means that E is negative, and that will be the non-spontaneous process. And at the state of equilibrium, you know very well that at equilibrium E is equal to 0, and because E is equal to 0, so delta G is also equal to 0. That is true at the equilibrium. So there are three cases: spontaneous process, delta G negative, E positive; non-spontaneous process, delta G positive, E negative. And at equilibrium, there is no EMF of the cell, so E 0, it means that the Gibbs free energy, that is also 0. And this relationship is very important because this relationship is used in the NERNST equation to calculate the electrode potential or cell potential under the non-standard conditions. I have already delivered a lecture about the NERNST equation. The link is given in the description of this lecture. You can also study the NERNST equation easily. I have given the link in the description. So it was all about the relationship between Gibbs free energy and EMF of the cell. Take care a lot.